Hi, in this video I'm going to introduce you to properties. Properties are used to make data of an object available to other classes. They expose read and or write access to that data. Let's look at an example. Here I have a public class circle which has a private field, the radius. Let's assume I want other classes to be able to read that radius, maybe also to write on it, change it. Now the first idea might be, why not just make the field public? This way we can access it from a different class. That's totally possible, but it has a lot of disadvantages. You know, the upside, it's simple, it's concise, I keep my field-like syntax, but there are too many downsides. I lose encapsulation, I can no longer restrict my access to read only, I can no longer add input validation, I can also no longer add any additional logic. It's a pretty bad idea, so we won't do it. Let's look for another solution, maybe a getter and a setter. That's what we've been doing in Java for quite a while. And when I look at the same pros and cons, I can see they totally swapped. At this point, I have all the advantages of using methods, but I lost my concise field-like syntax. Couldn't we just find something that gives us both the great advantages of using methods and the beautiful, concise, field-like access? And that's exactly what properties are doing. So when I have a property, I have all the advantages of the getters and setters, which are my methods. And in addition, I also have the advantages of the concise, simple, intuitive access. So using properties seems like a really good idea. Let's have a look how they work. Properties combine the advantage of both fields and methods. To the user of the object, the property looks like a field. To the programmer who implements the class, the property looks like a method. It allows to specify one or two code blocks representing getter and or setter. So here I have a property, and you can see we have an access modifier, type, property name, and inside my property declaration I have get and set, no parameter list. So this is different from Java. We don't have two separate methods. It's one property that has get with a code block and set with a code block. But those code blocks correspond to the method body of the getter and the setter. Notice that properties have an uppercase initial. So this is the naming convention. Properties uppercase initial, just like methods in C# have an uppercase initial. Here we have an example that includes an implementation for the get and the set code blocks. Notice the backing field. The property exposes the data to other classes. However, there needs to be a storage location that actually stores the data. We talk about a backing store, and if that storage location happens to be a field, we talk about a backing field. Also, notice the keyword value. Value is whatever happened to be on the right-hand side of the assignment operator when we assign the value to the property. Here we have an example of a property that performs input validation. We have a property called second, and second models the seconds of a clock. So my possible values are anywhere between 0 and 59. When we return the value here in the body of get, we just return whatever value is stored in our backing field, second. However, when we accept a new value, when the user chooses a new value, we want to make sure it is anywhere between 0 and 59. If that is not the case, then we just don't assign it to our backing field. Now, another example. Here we have a property that performs some application logic. Again, we are in our example of the circle. we have a backing field which is the radius, but now we want to have a property that is a diameter. So rather than storing diameter and radius separately as two fields, which could lead to inconsistencies, we have one backing field, which is the radius, and we just return twice the radius when the user needs the diameter, or we set half the value to our radius, half the value that the user chose as diameter. We can also restrict the access. So I might have a property, which is my GPA, public property. Anybody can read it. However, not everybody is allowed to update and change the GPA. This is something that can be only handled within my class. So the setter is private, the getter is public. I can restrict the access of either set or get, but only one of those two choices, not both. In this example, we provide read access only. So we have a social security number. Once it has been initialized, let's say in the constructor, nobody can change it anymore. However, the value can be exposed to other classes. It's also possible to have write access only. This is fairly rarely done. One example would be the password, that the user is allowed to write a password, but nobody is allowed to read it. Now let's have a second look at the simple example of the radius that we had before. No additional logic has been performed besides accessing the backing field. So this property is the counterpart to having getters, setters automatically generated by an IDE in Java. In such a situation, we ask ourselves, couldn't the syntax be simplified? Couldn't the backing field be generated automatically? And also the code blocks of the get and set. Do we really need that many curly braces? Couldn't we just have a semicolon after the get and set? And the answer is yes, we can. So here you can see all we have left is the access modifier, the type, property name, and then in this case we specify that we want both get and set generated. We call this an auto-implemented property. You can see access modifier, type, property name, and then in curly braces we specify both get and set, or maybe just the get. So the example we had first was the radius. We could also use our own type. Let's say I have a football player type, and I'm creating a quarterback of type football player. I could also have a generic type, like a list of cards. This is my deck. I could also have a restricted setter. For example, a public GPA with a private set. I could also have a get only. This is possible since C# 6.0. Before that, both get and set had to be specified in an auto-implemented property. There's one more thing you can do since C# 6.0. You can initialize a property as you declare it, very similar to the way you can initialize a field.